rolled up to Seavers and said, let's do it. Seavers like,
Sup, buffet? Let's get right to it.
and I'm like, I don't know nothing about significance test. And Seavers like,
We gon' review. Follow me.
ooh, is that the vocab?
Yeah, it's got everything you need to know. Like how to make a significance test go.
Test and claims about the population?
Indeed. Now all you need is some hypotheses.
My moped gets about 8 miles per hour most of the time.
That'll be our null hypothesis.
Because that's what the claim is?
Yep. And I claim that your moped ain't the best.
And that's the alternate hypothesis?
Yep, now time for a one-sided test.
Alpha level is 90% because I know the moped'll do.
You make it too easy, let's go 95%.
I'll speed down the lanes 50 different times.
And I'll randomly select 30 different pickup times.
Then we gotta check if the data is normal.
And keep the gas tank levels optimal.
Subtracting the parameter from the sample stat?
Sweet sauce. Now let's divide by the standard deviation of the statistic.
So what do we do with the t statistic?
We take n and minus 1 to find our degrees of freedom.
So then we hit them with the critical value?
That's right. Now just follow the degrees of freedom and the alpha level.
So if you're wondering how it works, the graph will show you.
Yep. Here's the rejection region and the different levels.
If this was two-sided, then two sides would be shaded.
Yep, but it's one side, so only one side after the critical point is faded.
If our t-stat is beyond the critical value, then the claim is proven incorrect.
Oh heck no, bruh. You got it all wrong. I'm afraid you just lost all respect.
Alright, we can't prove anything. We can only reject the HO.
Hey, that's right. You can only conclude sufficiency of evidence and take action against HO at the significance level.
That was super long and didn't rhyme.
It's okay, because it's time for round 2 of the course.
Woo! Let's learn some stat again. Gotta love stat early in the morning. Woo! We all love stat.
I really enjoy that.
Let's move on.
Okay. There are some important notes, so I'll let you carry on.
Okay, what's the difference between Z and T?
In the T, we use degrees, but in Z, the sample size is sweet.
So in that case, the sample size doesn't influence our statistic?
That is correct.
Well, what if there are only two sets of data?
For this review, I'll only discuss if they're from the same strata.
The same population?
Yes, this rhyming thing is tricky, but that's a paired significance test if they're from the same place.
So how would you test for a difference between two sets of data from the same place?
You would subtract each data point from the same place and then run the t-test on the difference.
That makes quite a bit of sense.
Oh yes, it does.
But wait, don't we usually not use the variance of the population?
Indeed. So we substitute it with the standard deviation of the sample divided by square root of n as rationalization.
All of this by hand is a bit complicated. Can I make it less R-rated?
Easily. All you gotta do is whip out a calculator.
That thing is fantastic. All I gotta do is pull up stat, then I just scroll over to the test and select T or Z stat. If I have the data in a list, it'll do it all for me, but if I have the stats, select stats after filling in the appropriate data.
Hold up. Careful on that last section, because you gotta say if the HA is greater than or less than.
Cool, I got it. I'm feeling a little bit funky with it, because I have the weird thing now called P.
It's exciting, right? Because you don't have to even need the critical value if you have P.
So if P is bigger than alpha, then that's all I need to see?
That's right.
Yippee!
Now, back to our moped problem.
If our HO is mu equals 0.7, then our HA is mu is less than 0.7, right?
Right, and our alpha level is 0.05.
A nice safe bet to avoid wrongly rejecting the HO, which would be a error.
We wouldn't want that. It'd be a type 1 error.
And a type 2 error is failing to reject the HO when it is false.
You've learned quite a lot.
So now that we have our data labeled, do we plug it into the formula?
Yep, because our assumptions were checked and we are all set.
So in conclusion, there is sufficient evidence to reject the HO at the 95% level because the p-value, 0.005, is lower than that of the alpha level, 0.05, and the t-statistic, negative 2.739, has an absolute value greater than that of the critical value of 1.06. Does this mean that the moped doesn't usually make it up to 8 miles per hour?
It only means that the data shows a correlation that doesn't support the original claim. It doesn't prove anything.
What about if there is a proportion?
Just throw in an extra assumption that n times p is greater than 10 and that n times 1 minus p is also greater than 10.
I see. I think we're ready for our final course run through.
I agree.
Woo! Let's get some stat again. Gotta love stat early in the morning. Woo! We all love stat. Woo! Let's learn some stat again.
Gotta
love stat early in the morning. Woo! We all love stat.